This episode is brought to you by Only Natural Diamonds. Do you know the difference between a laboratory-grown diamond and a natural diamond? Lab-grown diamonds are mass-produced in weeks and have distinct patterns. But natural diamonds are over 1 billion years old and support the livelihood of millions of people. Around 80% of the value of every rough diamond remains in local communities and supports infrastructure, healthcare, education, and more. Learn more at naturaldiamonds.com.
Toxic therapy from your vape.
Can't sleep? Listen to my voice. Your friends all bailed on you. Your crush thinks you're thirsty. The planet is dying. Keep obsessing till 5 a.m.
Vaping nicotine is associated with sleep problems. Find solutions at thetruth.com.
This is SpaceTime, Series 24, Episode 60, for broadcast on the 28th of May, 2021. Coming up on SpaceTime, NASA's Perseverance rover starts its science mission on the Red Planet, a new theory on how Mars got its 2 moons, and Starlink and OneWeb have their first near-miss in orbit, averting collision by just 57 meters. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's newest Mars rover Perseverance has started its science mission, searching for signs of past microbial life and studying the geology of the ancient lakebed of Jezero crater. Perseverance has been busy serving as a communications base station for the Ingenuity helicopter during the rotorcraft's historic test flights on the Red Planet. But the rover's now focusing on its own science mission, using its instruments on rocks and the Jezero crater floor. The data these investigations turn up will help scientists create a timeline of when the ancient lake formed, when sediments began piling up in the river delta that formed in the lake, and when it all dried up. Understanding this timeline will help date rock samples to be collected later on in the mission, samples that might be preserving a history of ancient microbial life, if it ever existed on Mars. A camera called Watson at the end of the rover's robotic arm has taken detailed images of the rocks, and a pair of zoomable cameras that make up the Mastcam-Z imager on the rover's head has also surveyed the terrain. Scientists have already used a laser instrument called the SuperCam to zap some of the rocks in order to study their chemistry. These instruments, together with others, have allowed scientists to learn more about Jezero crater and focus on areas worth further study. One important question scientists want answered is whether these rocks are sedimentary, like sandstone, or whether they're igneous, formed through volcanic activity. See, each type of rock tells a different kind of story. Some sedimentary rocks, formed in the presence of water from rock and mineral fragments like sand, silt, and clay, are better suited to preserving biosignatures or signs of past life. Igneous rocks, on the other hand, are far more precise geological clocks that allow scientists to create an accurate timeline of how an area formed. One complicating factor is that the rocks around Perseverance have been eroded by wind over eons and then covered with younger sand and dust. Now, on Earth, a geologist would simply trudge into the field and break a rock sample open to get a better idea of its origins. Now, while Perseverance doesn't have a rock hammer, it does have other ways to peer past millennia's worth of dust. When scientists find an especially enticing rock, they can reach out with the rover's arm and use an abrader to literally grind and flatten the rock's surface, revealing its internal structure and composition. Scientists can then gather more detailed chemical and geological information using other instruments. It's all part of the prelude to what could be one of the most exciting scientific planetary assignments ever undertaken. We'll keep you informed. This is SpaceTime. Still to come, a new theory on how Mars got its moons. And Starlink and OneWeb have had their first close encounter in orbit, with 2 spacecraft missing each other by just 57 meters. All that and more still to come on SpaceTime.
At Capella University, you'll get support from people who care about your success. From before you enroll to after you graduate, pursue your goals knowing help is available when you need it. Imagine your future differently at capella.edu.
Scientists have come up with another new hypothesis to try and explain how Mars got its two moons, Phobos and Deimos. The origins of the Martian moons has long been an ongoing area of debate for astronomers. Compared to the Earth's dwarf planet-sized moon, the irregular potato-shaped Phobos and Deimos are tiny. Phobos is just 22 kilometres wide. That's 160 times smaller than the Earth's moon, while Deimos is even smaller still at just 13 kilometres across. And their orbits are also very different. Phobos circles the red planet every 7.5 hours at an average distance of just 9,377 kilometres. Deimos, on the other hand, orbits at a more distant 23,460 kilometres in just over 30 hours. It's long been suggested that both are captured asteroids. The problem with that idea is that captured asteroids would have more eccentric orbits in random inclinations. On the other hand, their almost circular orbits along Mars's equatorial plane suggest that they formed around the red planet itself. But if they did form around Mars, how? One idea involves a large celestial body in orbit around Mars being impacted by another object, causing both bodies to smash apart and eventually coalesce into Phobos and Deimos as we see them today. But a new hypothesis, reported in Australian Sky and Telescope magazine, suggests they were created by an object impacting the Martian surface and then blasting away ejecta into orbit, which eventually coalesced to form the two moons. With the details, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, scientists are still trying to figure out how Mars came to acquire its two small potato-shaped moons called Phobos and Deimos. And these are tiny moons. They're nothing like our moon. They're just really, really small. Phobos as I say, it's potato shaped, so it doesn't have a one particular dimension, but its average width is about 11 kilometres, which is about 7 miles. Deimos is even smaller. It's only about 6 kilometres wide, so it's about 3 miles across or so. So they are really, really tiny, and they're the only moons that Mars has, and they just trundle around the planet, minding their own business. Phobos is interesting because it's actually losing altitude as each day goes by. It's about 2 centimetres per year. It's drifting closer and closer to Mars. So they reckon in about 20, 30, 40 million years or so, it's either going to crash into the planet or be torn apart by tidal forces when it gets too close. No one's really sure yet what's going to happen, but something
One
will
ring
happen
to rule them all.
To rule them all, yeah. Well, we'll come to that because no one is sure yet how they came to be orbiting Mars. All sorts of hypotheses have been proposed over the years, but there are a couple that are currently in vogue with scientists. One has it that a large rocky body of some kind crashed into Mars a long time ago, and that spewed rocky debris out into orbit where these two moons finally coalesced. And there was probably lots of other debris floating around as well, but that eventually fell back down onto Mars, and the sort of orbital space above Mars became cleared apart from just these two moons. Nothing really controversial about that. That sort of idea has been around for a long time. The other idea, though, is interesting, and it starts with the same sort of collision with some big rocky body crashing into Mars, and that then followed by the formation of lots and lots of moons orbiting around the planet that have formed from the debris that got thrown into orbit. But some of these moons will then eventually break up again due to tidal forces, and then you'll get a smaller number of moons forming out of the debris of them, and you just sort of rinse and repeat, and you end up in the end with just two of them. So that's been taken seriously by a lot of people. So that could explain certain characteristics of why Deimos is further out and Phobos is closer in, and how they ended up in their particular orbits, and why Phobos is losing altitude slowly, and yada, yada, yada. So no one really knows for sure yet, but those are the two main ideas.
It's
so
a huge ongoing debate, isn't it? We've got all sorts of hypotheses out there. I was reporting just the other week on another two options, one involving Phobos and Deimos being formed by a collision between two objects in orbit around Mars, and then the other option is they were simply captured asteroids, but their orbits don't justify the captured asteroid story. So
no, that used to be the main, a long time ago, that used to be the main idea. They just, because they look like asteroids, they're about the size of asteroids, so they were probably captured asteroids. And that was a very common thought. Seems pretty straightforward. An asteroid gets too close, gets captured into orbit. But they're pretty certain now that's just not the case for all sorts of reasons. Some of these mysteries, though, might be solved, or at least, if not solved, we might have few more bits of information to plug into them later this decade, because Japan's going to be sending a mission there called the Martian Moons Exploration Mission. That's an imaginative title, isn't it? The Martian Moons Exploration Mission. And it's going to head to Phobos. It's going to launch in 2024. It's going to go to Phobos. It's going to land there, and it's going to take some samples and blast off and bring them back. So that should be pretty specky. The Russians have tried this long time ago.
Phobos Grunt, yes.
Yeah, and they it didn't work. There were a whole string of Mars mission failures back then. So I still remember there was another mission called Mars 96 that was sent off, and it got launched. Got launched, and it didn't get out of Earth orbit. Really, it didn't even make it into Earth orbit much. And I remember this because I woke up early that morning, and
this was the Proton rocket failure, wasn't it?
I think it was. And the word was that this thing was going to come back down to Earth within the next orbit or two, and it might crash into Australia.
Yeah.
And I remember I was doing lots of radio stuff at the time, and I rang up the studio and said, "Hey, there's this big story. This Russian thing might be going to crash into Australia, and it's got a bit of plutonium on board and all that sort of thing. So it could be a problem." They said, "Oh, don't bother us with that. We've got really big, important political things going on this morning," and blah blah blah. Well, they phoned me back 20 minutes later and said the Prime Minister's about to have a press conference about this.
Yes.
About this Russian thing coming down.
Yes,
can you talk to us about it? He and John Howard, the Prime Minister at the time, had a press conference about the possibility of this thing crashing into Australia for Mars 96. The good old days when missions to Mars failed all the time.
Yes, sometimes because they simply confused imperial and metric measurements.
Yes, all sorts of reasons. In fact, in the latest issue of Australian Sky and Telescope, my little editorial piece that I write each time, I make the point that Mars was the first planet that I had identified in the night sky when I was a teenager. It was the first one I learned how to pick out. It was pretty easy because it was red. So I've got a bit of a soft spot for Mars, and that was about 1980. Well, at the time, the Viking missions were still on Mars, and it was the year after that, it was 1981, I think it was, that they switched off one of the Vikings, and a few years after that, 86, I think it was, they switched off the other one. And then there was just a long period of a decade or more where other Mars missions were attempted, but they all failed. And it took until 1997 when the Mars Pathfinder mission eventually got there with this little Sojourner rover to be the next successful mission after the Vikings. So there was a long period there where everything was just going wrong with Mars missions, and a few after Pathfinder as well. But they obviously have learned their lessons, because the missions, look at Perseverance, they're doing it really well these days. They know what they're doing.
I remember staring at an image in the school library taken by one of the Viking landers from the surface of Mars, and just looking at that then red landscape with this green sky. That's the way it looked in the newspaper image anyway. And I was just fascinated with it. I
thought you were going to talk about Cydonia and the famous face on Mars.
Oh, that came later.
That came later. Oh, that was a
it's
lot
real,
of
you know.
the old face on
it's
Mars.
Aliens.
Aliens, yeah. People made a lot of money out of that.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. This is SpaceTime. Still to come, Starlink and OneWeb have their closest encounter yet, with two of their satellites involved in a near miss, passing each other in orbit by just 57 metres. And the European Space Agency's Vega rocket returns to flight status following last year's multi-million-dollar launch failure. All that and more still to come on SpaceTime. Starlink and OneWeb have had their first close call in orbit, with spacecraft from the two companies missing each other by just 57 metres. For years, scientists have been warning that the massive broadband internet satellite constellations now being launched by companies like SpaceX's Starlink and OneWeb are a recipe for disaster, with collisions inevitable. But despite the warnings, SpaceX has already launched well over 1,600 Starlink satellites, with some 30,000 more planned. And OneWeb is now joining the club, with 146 of its own spacecraft now in orbit and hundreds more expected. And now all those warnings are starting to come to fruition. The two companies received several red alerts from the US Space Force's 18th Space Control Squadron, warning of a possible imminent collision. The red alert came after the European Space Agency contracted Roscosmos to launch 36 OneWeb satellites on a Russian Soyuz rocket. Although the OneWeb satellites are designed to orbit at a higher altitude than the Starlink satellites, they still need to pass through the Starlink's orbits in order to reach their own operational orbital altitudes. And that's where things got tricky. The two spacecraft flew past each other at several tens of thousands of kilometers an hour, just 57 meters apart. SpaceX claims it has an artificial intelligence-powered automated collision avoidance system on each of its satellites. But it decided instead to deactivate the system, allowing OneWeb to alter the course of one of its satellites instead. Now, on this occasion, the emergency avoidance maneuvers were successful. But it raises the question, how many more close encounters will they face before a catastrophic collision actually occurs? And when that does, how long will it be before we end up with some sort of Kessler syndrome, where debris from one satellite collision ends up smashing into other spacecraft, causing further debris, which then cascades into yet more spacecraft, causing even further debris, eventually rendering space navigation impossible? This is SpaceTime. Still to come. The European Space Agency returns Vega to flight status, successfully launching a Vega rocket for the first time since last November's multi-million-dollar failure. And later in the science report, bipolar disorder found to have genetic links to schizophrenia and major depression. All that and much more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
The European Space Agency has successfully launched its first Vega rocket since last November's multi-million-dollar launch failure. The return to flight status mission from the European Space Agency's Kourou spaceport in French Guiana carried the Pleiades Neo 3 Earth observation satellite. The spacecraft is the first high-resolution satellite for a new Earth observation constellation operated by Airbus.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage P80 et décollage V18. Propulsion est nominale.
We never get tired of seeing those launches, do we?
No, it's always something very beautiful to look at.
So, we're into it now. What happens? We track it now. Tell me what happens now.
Yeah, now we are in the phase that we call the PAT phase. It's the name of the first stage boosters, which allows us to get far from the launch pad. During this phase, we burn solid propellant. So the name of PAT comes from the amount of propellant that we have on board. So it's roughly 80 tons of propellant, slightly more. And during these phases, the launcher provides thrust and accelerations, and the separation of the stage will be triggered when the acceleration will get below a predefined threshold in order to get use of this mass, which is useless once you have used almost all the propellant inside.
When will the first separation take place?
The first separation will take place around 2 minutes after liftoff, so we should see it in a few seconds.
And this is the next really important stage.
Yes. And the separation of the PAT has just been confirmed, and we have the ignition of the second stage, which we call the Zefiro 23.
So confirmation, the first separation has gone ahead as planned, which is what we were looking for. Yeah. What happens next?
Now it's the job of the second stage, which will increase still the launcher velocity and the altitude in order to provide additional energy to the launcher. And then when it will complete its job, it is exactly the same principle as for the PAT. It means once we have used almost all the propellant that is inside the stage, we will trigger the separation, once again based on the detection of the acceleration.
This whole operation is supposed to take, what, an hour and 40 between launch and dropping off all the different satellites?
Between the liftoff and the separation of the Pléiades Neo 3, we have around 55 minutes. And up to the separation of the auxiliary passenger, 1 hour and 40 seconds, more or less.
As well as the primary payload, the mission also carried the NorSat-3 Norwegian observation microsatellite, which will be used to detect radar for maritime navigation, and 4 small CubeSats for operators Eutelsat, NanoAvionics, Aurora Insight, and Spire. The flight was the third from the Kourou spaceport this year and the 18th launch of a Vega rocket. The mission, Arianespace Flight VV-18, came just 6 months after losing a Spanish Earth observation satellite and a French research probe during a spectacular November 17, 2020 launch failure. That was eventually traced to quality control manufacturing errors. It seems wires were crossed on the 4th stage thrust vector control actuators, causing the engine to move its nozzle in the wrong direction during ascent to orbit. The issue resulted in the rocket losing control and tumbling back into the sea after upper stage ignition around 8 minutes into the flight. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. A new genetic study of 41,917 people with bipolar disorder has identified genetic links to both schizophrenia and to major depression. The findings, reported in the journal Nature Genetics, identified 64 genetic locations associated with bipolar disorders, 33 of which were new discoveries. 27 of the 64 genetic locations had previously been linked to schizophrenia, and 7 had previously been linked to major depression. The study found that bipolar 1 was more genetically correlated with schizophrenia, while bipolar 2 is strongly correlated with major depression. A new study has found that 31% of dogs and 40% of cats tested positive to COVID-19 after their owners were also diagnosed with the disease. The findings, reported in the journal PLOS ONE, confirms that pet owners are passing on the illness to their four-legged companions. Researchers tested the pets of people in Rio de Janeiro who have been diagnosed with the disease between May and October 2020. In all, 29 dogs and 10 cats belonging to 21 COVID-19 patients were examined. Scientists found 9 dogs, or 31%, and 4 cats, 40%, from 10 households, that's 47.6%, containing COVID-19 sufferers, tested positive from 11 to 51 days after human COVID-19 cases experienced their first symptoms. The study shows that people with COVID-19 should avoid close contact with their pets during the time of their illness. Over 3.5 million people have now been killed by the COVID-19 virus, with another 166 million infected since the deadly disease first emerged in Wuhan, China, and was spread around the world. A new species of ceratops or horned dinosaur has been identified in New Mexico. A report in the journal PalZ claims that Ceratops soleil was a relatively small ceratopsoid dinosaur, growing to around 4.6 meters or 15 feet. That's only about half the size of a full-grown Triceratops. Fossilized parts of the herbivore's skull and lower jaws, forearm, hind limbs, pelvis, vertebrae and ribs were found in 82-million-year-old Cretaceous period strata from the Menifee Formation in northeastern New Mexico. Scientists have successfully sequenced and analyzed the genomes of 7 2,000-year-old Judean date palms from Israel and Jordan. The findings, reported in the journal The Proceedings of the National Academy of Sciences, provides new insights into the spread of domesticated date palms across the region. Date palms are the iconic perennial plant of the deserts of Western Asia and Northern Africa. They're believed to have been domesticated around the Arabian Gulf some 7,000 years ago. Date palms grown in antiquity around Jericho and along the Dead Sea in Judea were referred to as Judean date palms. But studying their original genomes has only become possible after several ancient seeds were germinated into viable plants. The seeds, radiocarbon dated from the 4th century BCE to the 2nd century in the Common Era, were recovered from archaeological sites at Masada, Qumran, and Wadi Muka in the Judean desert. Scientists found that the oldest seeds from the 4th to the 1st century BCE are related to modern Western Asian date varieties, but the more recent material showed increasing genetic affinities to present-day North African date palms. Well, despite society's growing dependence on science, it seems the anti-science movement is gaining strength globally. A report in the journal Scientific American puts the anti-science movement now on par with terrorism and nuclear proliferation as a significant threat to global security. Tim Minham from Australian Skeptics says rejection of mainstream science and medicine has become a key feature of the political extreme in the United States and increasingly around the rest of the world.
Anti-science is an issue. It's been an issue for a while. The Scientific American article points out about the problems in Stalinist Russia in the 30s and 40s when a fellow named Lysenko was a scientist who got the ear of Stalin and was promoting all sorts of pseudoscience about agriculture, specifically, about a whole range of things. Anything that was against it was Western propaganda. And Stalin put this guy's Lysenko's prognostications into practice, and they basically had catastrophic harvest failures, famine, and a lot of people died because of it. They starved to death in Russia because of this anti-science person who had the ear of the people of power. Lysenko's thing was pure politics.
People do get scared when they hear about chimera monkey-human hybrid cells and things like this.
There are certainly areas where people do get...
That Frankenstein sort of stuff does get scary, and people are concerned about that.
They are, and understandably. I mean, the same thing you can easily say towards the vaccines when politicians are saying, look, we got this in 1 year where it normally takes 5 to 10 years. You think, well, that's going to scare people, and understandably, you make them hesitant at the very least towards having their, as it has proved to be, about vaccines. You think, well, why does it normally take 5 to 10 years?
Stuff now, yeah.
And I know we've discussed this before, actually, but you can understand people being concerned about that it's almost too quick, but too successful, which is obviously there are issues which have arisen, which people say, they told you so, shouldn't have done it in 1 year. But generally speaking, there is an anti-science movement based on politics and ignorance. How's that for a broad brush statement? But it's definitive, if nothing else. But there often has been people anti-science, but this is on a scale now where you're probably sort of seeing it in many, many areas where you can almost, if you say you're a scientist, you should be embarrassed, almost as embarrassing as being an accountant.
Or a journalist.
Or a journalist, yeah.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.